Okay, Assalamualaikum and a very good morning everyone. Hope everything is okay. Today, let us proceed with our topic chapter 9, model of chemical bonding. Okay, from the previous lecture, we already learned about ionic bonding, covalent bonding, and today we gonna to finish our topic, our chapter 9 topic about bond energy and chemical change, electronegativity and bond polarity, and metallic bonding. Okay, remember the meaning of bond energy? Bond energy is in covalent compound. Bond energy is energy needed to overcome the attraction between electron and nuclear in covalent bond. Okay, during reactions, there is bond broken and bond formed. And the difference between these will result in the enthalpy of reaction. Enthalpy reaction, it is positive, mean energy is absorbed, or negative, energy is released. Okay, and it depends on the difference between the bond energy of bond broken and bond formed. Okay, in order for you to calculate the enthalpy reaction for the formation of HF, you must calculate the bond energy for each reactant and bond energy for each product. The difference between the bond broken and bond formed will result in the enthalpy of reaction. If the sign is positive, mean that the energy, the heat is absorbed. If the sign is negative, it will show you that the energy is released. Okay, released. Okay, during the bond form, as you can see here, the energy is released. Mean that during the formation of bond, energy is released and the sign is negative. During the bond broken, the energy is absorbed, so that's why the sign for total bond energy for reactants is positive. Okay, you can use the bond energy to calculate the enthalpy reaction for the combustion of methane. First, you must calculate the bond energy for each bond in reactant. For example, this reactant has four bonds, so 413 must time with 4, and this reactant has one bond each. Since it has a 2, so 498 must time with 2. So you calculate this, then you will get this amount, meaning that 48 energy is needed to break the bond. Okay, then you also must calculate the bond energy for each bond in product. For example, here this product has 2 bonds, so 799 must time with 2, and this product has 2 bonds for each, and so 467 must time with 4, 1 2 3 and 4. So when you calculate all the bond energy in products, you will get this amount, meaning that negative meaning that energy is released during the formation of bond. Then you calculate the difference between bond broken and bond formed, so you will get this enthalpy of reaction, meaning that negative 8.8 energy is released during combustion of methane. Okay, this example of questions that require you to calculate the enthalpy reaction for the chlorination of methane to form chloroform. Remember, during the chemical change, there is bond broken and bond is formed. Okay, first you must calculate the bond energy for each bond in reactants and bond energy in each bond in products. The difference between the bond formed and bond broken will result in enthalpy of reactions. Okay, try calculate the bond energy in each bond in reactants and the bond energy in each bond in products, and the difference between bond broken and bond formed, you will get the enthalpy reaction. Okay, this figure show you the relative bond strength and energy from fuel. As we know, fuel is react with oxygen and release energy. Okay, from this between alkane and alcohol, which one is better source of fuels? Let's see the bond energy for each reactant. For example, alkane, it has C, C and CH bond. So the energy that required to break the bond is 7,600 kilojoule per mole. While alcohol, it has CO and OH bond and 8,625 kilojoule mole energy is needed to break this bond. Okay, alkane react with oxygen and it will release energy, and the enthalpy of reaction will be negative since energy is released, and alcohol react with oxygen also will release the energy and result in enthalpy of reaction. As we can see here, the enthalpy reaction of alkane is greater than the enthalpy reaction of alcohol, meaning that alkane will release energy. It will release more energy compared to alcohol. We can calculate that alkane that has weaker bond will yield more energy compared to alcohol that has a stronger bond, since more energy is needed to break the bond for alcohol, and it has less it releases less energy compared to alkane. Okay, this table show you our source of high energy food such as fats and carbohydrates. Compared to carbohydrate, fat gives us more energy. Fat release more energy compared to carbohydrate. This is because fat and carbohydrate has CO, C double bond O and CH bond. But fat has less bonded to O compared to carbohydrate. So less energy is needed to break the bond in fat compared to energy needed to break the bond in carbohydrates. Therefore, fat yield more energy compared to carbohydrates. Okay, from previous slide, we learned about bond energy and enthalpy of reactions. Okay, next, we will learn about electronegativity and bond polarity. Okay, polar covalent bond occur when the shared pair of electron between the atom is not equally shared, but the electron remain closer to one atom than the other. And electronegativity is the ability of an atom to attract the pair electron. We call it electronegativity. The more electronegative atom we call partially negative, and less electronegative atom we call it as partially positive. Okay, here you can see the bonding between the models, and in polar covalent we can see the unequal sharing, the pair of electron not shared equally between the atom, where the electron is closer to one atom than the other. Okay, the atom that less electronegativity we call it partially positive, while the atom that more electronegativity atom is partially negative. And here you can see the equal sharing pair of electron between the atom, and we call it pure covalent. And this is pure ionic, where the cation and anion is attracted to each other, and polar covalent bond are much more common than pure ionic and pure covalent. Okay, here you can see the electronegativity for each element, and the electronegativity varies depend on the position of the element in the periodic table. And you can see the electronegativity decrease down the group for this group 1, and the electronegativity in this period increase across this period. Okay, so you need to relate the electronegativity with the position of the atom in the periodic table. Okay, remember the meaning of electronegativity. Electronegativity is the ability of an atom to attract electron, and the most electronegative element is fluorine. Okay, in general, the electronegativity decrease down a group as atomic size increase, and the electronegativity increase across a period since the atomic size decrease across a period. Okay, since nonmetal receive electron, and it tends to be more electronegativity than metal. Okay, next let's see how we relate the electronegativity with the reactivity of elements for metals and nonmetal. Okay, for metal, low electronegativity means it's easy to oxidize, means it's easy to release electron, for example group 1 and group 2. High electronegativity means it's hard to oxidize, means that it's hard to release electron. So reactivity decrease across row as electronegativity increase for metal. For non-metal, oxidation power means that how easy it to be reduced, and it's parallel with electronegativity. Oxidation power increase across row as the electronegativity increase, and oxidation power decrease down column as electronegativity decrease, meaning that the increase the electronegativity mean that the non-metal tend to easy to be reduced. Okay, here you can see how to relate the electronegativity and atomic size. Okay, as the size bigger down the group, the electronegativity decrease. As the size small decrease across a period, the electronegativity will increase. Okay, we can use the electronegativity to calculate the oxidation number, where the oxidation number is calculated based on the difference between the valence electron and the total of the shared electron and unshared electron. Okay, let's see this example, how you calculate the oxidation number of hydrogen and chlorine. Okay, here chlorine is more electronegativity than hydrogen. So to calculate the oxidation number of chlorine, you must know the valence electron and calculate the shared electron. Since the chlorine is more negative, so all the shared electron is assigned to chlorine, and the total number of unshared electron is 6, 2, 4 and 6. So the difference between the valence and the shared and unshared, you will get the oxidation number of chlorine negative 1. For hydrogen, since it is less electronegative than chlorine, so the shared electron is 0 since all the shared electron is assigned to chlorine, and the total number of unshared electron is 0. Okay, so calculate the valence electron and minus with the total shared and unshared, so you will get the oxidation number of hydrogen is positive 1. Okay, polar bond can be shown by polar arrow and also by this symbol, partially positive and partially negative. Since fluorine is more electronegativity than hydrogen, so the arrow will be pointed to more electronegative atom. Okay, here you can see the electron density distribution in H2, F2 and HF. As you can see here, the electron is equal shared in non-polar, but the electron is unequal shared in polar bond. Okay, HH and FF is non-polar due to there is no electronegativity difference between the atoms, so the bond is non-polar. In in H and F, there is electronegativity difference between the atom, so that's why the bond is polar, and you can see the arrow is pointed to the more electronegativity atom of fluorine. Okay, here you can see the electronegativity range for classifying the partial ionic character of bond. Okay, here if the range between 0 to 0.4, it is categorized as mostly covalent. And if the value is between 0.4, it is categorized as polar covalent. And if the value is between this, the character of bond is mostly ionic. Okay, this graph show you the relationship between the property of bond with electronegativity. As you can see here, the electronegativity in the range of 0 until this, the property of bond tend to be covalent, and the electronegativity at this range of electronegativity, the bond property tend to be ionic. Okay, for lithium fluoride, it is very highly ionic, but some electron shed occur between the ion in the gaseous ion pair. Okay, you can use the electronegativity value to determine the bond polarity. Okay, for example, use polar arrow to indicate the polarity of each bond. Okay, so you must know the electronegativity of the atom, and the arrow must be pointed to atom that more electronegative. Okay, you also can you can also rank the bond polarity based on the difference in electronegativity of the bond. And for example, here you can see HO, the difference in electronegativity is bigger compared to HN and HC. So the polarity for HO is greater compared to HN followed by HC. Okay, as you can see here, the electron density in this region, in this bond, increase across the period, and also the electron density in this region also increase across the period, since the electronegativity Si increase across this period from Si to Cl. So that's why the electron density in this region increase in the bond. Okay, this graph show you the the relationship between the electronegativity and the type of the bond. And you can see here, as the electronegativity decrease, the type of the bond change from ionic to covalent. Okay, and also you can see also as electronegativity, the melting and the electrical conductivity also decrease because the bond type change from ionic to non-polar covalent. Okay, remember metallic bonding that we learned from our previous lecture? Metallic bonding involves the electron pooling between metal and metal. Electron C in metallic bonding propose that each metal contributes its electron to form delocalized electron, and the positive charge from metal lie in an orderly array within the electron C. All the metals share the same electron, and metal is held together due to the attraction of positive with the negative electron C of valence electron. Okay, metal are solid which have moderate melting point and high boiling point, as you can see from this table. Okay, melting point of metal decrease down the group but increase across the period. As can be shown in group 1 and group 2 metals here, the melting point for group 1 decrease down the group, and also group 2 also the melting point decrease down the group. Okay, compared to ionic compound can be cracked, but metal can be shaped and bent without crack due to the presence of electron C that allowed the metal ion to slide each other. Besides, metal also a good conductor electricity in solid and liquid state due to the presence of mobile electron C, and also it is a good conductor of heat.